Ladies and gentlemen, we are going to be looking in section 2.7, radical equation. So a radical equation is just an equation that has like a radical, a square root in it. And we're going to jump straight to a first problem, solve the equation. Here we have the square root of 2x minus 3 equals 5. So your strategy for solving radical equations should be to get the radical by itself first. So first you want to get the radical all by itself. Now in this problem, thankfully, we already have the radical by itself, right? We have radical equals 5, or radical equals 5. And the idea is what's under the radical is going to have some variable stuff, like 2x minus 3. And you want to eventually get x by itself. That's your goal, to get x by itself. So first I have to get rid of the radical. So to get rid of the radical, I'm going to start off by squaring both sides of the equation. So I'm going to square both sides of the equation. So squaring is the opposite of taking the square root. It's the reverse operation of taking square root. So we square both sides, and the square is going to cancel with the square root on the left side. And you're going to have 2x minus 3 equals, on the right-hand side, you have what? 5 squared. 5 squared is 5 times 5, 25. So what we've done, we've reduced this to a basic equation. From there, you just want to get the x by itself. So we're going to first get rid of the minus 3. So we're going to add 3 to both sides. And that's going to give us 2x on the left, an equal sign, and 25 and 3 on the right is going to give us 28. And then finally, we have to undo the multiplication by 2 there. On the x, we're going to divide both sides by 2. Here the 2's will cancel. And we'll have x equals 14. Now at this stage, this is only a potential solution. A potential solution. What you actually want to do, you want to go back and check every time. You want to check your solution to see if it works, because many times your solutions will not check out with radical equations. So you need to check them every single time. So I'm going to check x equals 14 back into the original equation. So I'm going to go back to the equation I got. 2 times a blank minus 3 under a radical equals 5. That was the original equation, right, before we squared both sides. So I'm going to plug 14 in, and I'm going to see if this checks out. So we're going to write down the square root on the left side. We're going to do order of operations. We're going to do what? 2 times 14. 2 times 14 is 28. So we got 28 minus 3. Is that equal to 5? Well, square root of 28 minus 3 is 25. Square root of 25 equals 5. Yes, right, the square root of 5. Square root of 25 is 5, so it's 5 equals 5. It checks out. So we're going to keep the solutions. We have one solution here of 14. All right, so let's do a number 2. Problem 2. Here we have the square root of x plus 5. And then after that radical, we have minus 8. Then we have equals 2. So your strategy here should be to get the radical by itself. Get the radical by itself. Here the radical is not by itself on the left-hand side, right? It's connected to this 8 through subtraction. So we have to get rid of that minus 8. We have to plus 8 to both sides to get the radical by itself. So we're going to have here square root of x plus 5. Negative 8 and 8 cancel, equals 10. All right, so I added 8 to both sides. So now that the radical is by itself, I want to get rid of it. So to get rid of the square, you do the opposite. You take, to get rid of the square root. To get rid of the square root, you do the opposite. You square both sides. So the red square cancels out the purple square root, and you're left with, on the left side, x plus 5 equals 10 squared. That's 10 times 10, that's 100. And then to get x by itself, finally, I'm going to subtract 5. I'm going to get x equals 100 minus 5 is 95. So that is a potential solution. Let's actually check it. Check. X equals 95. All right, so I go back to my original equation. I got a blank plus 5 minus 8 equals 2. Let's see if that's true. So in place of x, I'm going to put 95 there. All right, so let's do adding 95 and 5 together. What's 95 plus 5? That's 100. That's all under the radical. Then after the radical, we have minus 8, and then equals 2. Let's see, what's the square root of 100? Square root of 100 is 10, so we got 10 minus 8 equals 2. Is that true? Yeah, because 10 minus 8 is in fact 2. So you get 2 equals 2. It checks out. So I'm going to circle this x equals 95 here, because that is indeed a valid solution here. All right. Number 3. Let's say I got the square root of 4x plus 5. Square root of 4x plus 5. And then after that, we got a plus 9. That plus 9 is not under the radical. And all that's equal to 2. So if I wanted to solve this equation, I would want to get the radical by itself. So I got to get rid of that plus 9, because that plus 9 is not part of the radical. So I got to subtract 9 from both sides. So this would give me what? The square root of 4x plus 5. 9 and negative 9 cancel. Then we have an equal sign. And we have 2 minus 9. 2 minus 9 is negative 7. Now here's a question. Square root. Is it possible for a square root to be negative? No. Square roots are always defined to be positive. So we have the square root of 4x plus 5 is negative 7. So this is impossible. This is impossible. Impossible since square roots are positive. Well, at least 0. Are not negative. I'll say not negative. You can never have a negative square root. When you take the square root of a number, it's always greater than or equal to 0. All right, so it's impossible to square something and get a negative. It's impossible to square root something and get a negative, I should say. So that means this has no real solution. No real solution here. Or just say no solution, rather. Now, if you wanted to get fancy and actually work through this, you could try to work through this. So here's an attempt to work through. So I go back to my equation. I was at what? Square root of 4x plus 5. Equals negative 7. So let's go back to that equation. And if we wanted to try to get the x by itself, we'd first square both sides, right? We both square both sides to get rid of the square root. And we'd be left with, on the left, 4x plus 5, right? The square would cancel the square root. And on the right, we'd have negative 7 squared. Negative 7 squared means negative 7 times negative 7. That'd be 49. And from there, we would subtract a 5 from both sides to get rid of the plus 5. And we'd have what? 4x on the left equals 49 minus 5 is 44. And then get rid of the multiplication by 4 by dividing both sides by 4. And you'd get x equals 11 as a potential solution, right? Now, if you actually check this, we'll see it doesn't work out. Let's check. X equals 11. So I go back to the original equation, the square root of 4 times blank plus 5 plus 9 equals 2. So I'm going to go back, and in place of the blank, where the x was, I'm going to put an 11. All right, so we're going to work under the radical. We're going to have what? 4 times 11. 4 times 11 is 44, so we got 44 plus 5 under the radical. Then plus 9, and then equals 2. All right, so 44 plus 5, we're going to do that under the radical. That's 49, so we got 49. And then plus 9 equals 2. Square root of 49, what's the square root of 49? Square root of 49 is 7, so we got 7 plus 9 equals 2. So we get 16 equals 2, which is false. So it fails to check out. So that is not a correct solution. 11 is not a correct solution. So in fact, there is no solution. But I mean, you didn't have to go through trying to solve that. You didn't have to go through trying to solve that and then checking it to find out it didn't work. You could have said right up at the beginning, no solution, because you can't take the square root of something and get a negative. Square root of something is always positive, or it could be 0. For example, the square root of 0 would be 0. All right, so that's an important little lesson right there. I guess I want to do another problem here. And then we'll get on to, we'll take a break and do another video. We don't want to put too much in one video. To make these videos too long, it's not our goal. Let's say we got the square root of x plus 9, and then after the radical plus 3, and then equals x. So anytime you're solving a radical equation, remember, get the square root by itself, get the radical by itself. So first I'm going to get rid of that positive 3, so I'm going to subtract 3. Yeah, so this one's a little different because it has a variable x on the right side. But you still want to get the radical by itself. So I'm going to have radical x plus 9 equals x minus 3. So once you have the radical on one side, what you want to do, you want to get rid of the radical. In this case, you're going to square both sides to get rid of the radical. So I square the left side. I square the right side. So on the left side, the red square is going to cancel the purple square root, and I'm going to be left with x plus 9. That's the left-hand side. On the right-hand side, we're going to do x minus 3 squared. What does x minus 3 squared mean? It means x minus 3 times x minus 3, right? X minus 3 times x minus 3. That's what it means to square. So I'm going to have to FOIL out the right-hand side. I'm going to keep the left side for now. I'm going to have x plus 9 equals, what happens when you FOIL here? When you FOIL, you're going to do first, x times x is x squared. Outer, x times negative 3x is negative 3x. Inner, negative 3 times x is negative 3x. And last, negative 3 times negative 3 is positive 9. All right. So I'm going to copy it on the left side. I'm going to clean up the right side. I have what? X squared. When I combine my like terms here on the right-hand side, I got negative 3x, and negative 3x is going to mean negative 6x. And then I got plus 9. So notice that this is turning out to be a quadratic equation, right, where the largest power is a power of 2. So what we want to do, we want to get 0 on one side. Let's get 0 on the left-hand side. Get 0 on the left-hand side. We like our x squared to be the positive. And notice how x squared is positive already. So we want to keep x squared minus 6x minus 9 on the right side. We want to get rid of that x plus 9 on the left. So we'll just subtract an x from both sides. And we'll subtract the 9 from both sides. So on the left-hand side, we're going to get x minus x cancels. 9 minus 9 cancels. We're going to have a big 0. Then we'll have x squared, bring that down. Negative 6x minus x is going to give us minus 7x. And 9 minus 9 will give us 0. So we're left with 0 equals x squared minus 7x. 0 equals x squared minus 7x. Now this is just a quadratic equation, and we know how to solve quadratic equations from our previous section. This one you can solve by factoring quite easily. Notice that there's an x in common between the two terms. So I can factor out an x. And then I'm going to make a pair of parentheses. I'm going to ask the question, what times x gives me x squared? Well, x. And then what times x gives me minus 7x? Well, minus 7. So I have x as a factor and x minus 7 as a factor, and those are multiplied to give me 0. So by the zero product property, one of those has to be 0, so I'm going to set the first factor equal to 0. And I'm going to set the second factor equal to 0. So we have one of our potential solutions is x equals 0. That's only a potential solution. And the other one we want to solve all the way. We're going to add 7 to both sides. And we're going to get x equals 7 as a potential solution. Now remember I said potential solutions. You always have to check them when you're doing these radical equations, because sometimes you introduce these potential solutions that fail, and they're sometimes called extraneous solutions. So let's try x equals 0. Let's check it. I'm going back to my original equation, square root of blank plus 9 plus 3 equals 0. And I'm going to plug in place of the x, I'm going to plug in a 0. All right, so we have what? Simplify this, 0 plus 9. What's 0 plus 9? So we got the square root of, hold up, wrong color. Square root of 0 plus 9 is 9. So we got the square root of 9 plus 3 equals 0. Then we're going to do the square root of 9. Square root of 9 is 3, so we're going to have 3 plus 3 equals 0. 3 plus 3 is 6, so we get 6 equals 0, and that's false. I'm going to put a big X by it. So it fails to check out. Fails to check out. So we're going to X out the first potential solution, x equals 0. That does not work. Then we have to check our second potential solution. Let's check x equals 7. So let's see, what was the original equation? I forgot. There it is. The original equation, square root of blank plus 9 plus 3 equals blank. That should have been a 0 there. Yep, blue 0. All right, so here in this equation, we're going to plug a 7. So we're going to plug a 7 in place of where the x was and a 7 in place where the x was. So on the left-hand side, I'm going to do square root of 7 plus 9 is 16, square root of 16, and then plus 3 equals 7. And then we take the square root of 16, that's going to be 4. So we're going to have 4 plus 3 equals 7, and that's true, right? You get 7 on the left, 7 on the right, so it checks out. So that means you have a solution. So here you just have one solution. So initially it was suggested that we would possibly have 2, but one of them failed to check out. So we only keep the 1, the x equals 7. So always check these guys. All right, I think we'll just take a break and we'll pick up a second video on radical equations.